So hi, we are group 4 for Mobile Radio and Satellite Communications group. This is a final presentation for our task, the spectrum scanning. So we're working with a bandwidth of 1 to 2 gigahertz. So let's go into the presentation. First of all, I'm going to walk you through all the equipment and accessories that we use for our experimental work. First of all is this spectrum analyzer, a very advanced piece of technology. Next, another core piece component for our experiment is the StrobeSpec USLP 9142 antenna. So since we're working with 1 to 2 gigahertz of bandwidth, so the gain for this antenna is between 6.5 to 6.8 dB. And last but not least, we have the LR142 global coaxial cable. So we measured, I believe this is a custom piece of cable, so the length is 3 meters and the average loss is between 0.23 to 0.33. But after our conversion, because dB per meter, so after our conversion we found it's between, we can take the average as 0.85 dB. The maximum loss is between 0.33 to 0.46 dB per meter as well. So multiplied by 3 meters, we can get the average around 1.2 dB. Once again, the frequency range that we're working with is between 1 to 2 gigahertz. Next.
Okay, for this section, we do a measurement actually at level 4 tower block, Faculty of Engineering. And then the experiment was conducted as shown. The antenna itself was pointed out to the building, and then we uses these spectrum analyzers to do the scan. So what first we do was we actually did frequency, we control frequency by a start frequency of 1 gigahertz and ends at 2 gigahertz. So as you can see from these results, probably a bit small, then we will run the overall test to determine the peak of the current we receive. After that, then we will have a continuous sweep to set a continuous sweep until visibility of signal was shown. Until then, we sweep as a single sweep because the power received from the signal will fluctuating. So therefore, we use a single sweep in order to further study on the signal. After that, we repeat step 2 and 4 again. But because we know that the range is fall between 1.8 to 1.9 gigahertz, therefore we set a start frequency at 1.8 and stop frequency at 1.9. Next. Okay.
Okay, now I will just show our measurement result. So from this picture, we can see the peak signal is detected at the frequency which is closest to the 1.8 gigahertz in the range of 1 gigahertz and 2 gigahertz. Okay, next. And okay, then this one is a closed loop, means that this range is zoomed in. Okay, so we can also that this picture we have 4 bandwidth, so means that 4 peak now 1, 2, 3, 4. So in the range of a 1.8 gigahertz to the 1.9 gigahertz. So from the first peak, we can see from here the minimum the reading is start from the 1.805 gigahertz to the 1.832 gigahertz. Then the second peak is start from the 1.825 gigahertz to the 1.840 gigahertz. Then the third peak is start from 1.841 gigahertz to the 1.857 gigahertz. Then the fourth peak is start from 1.86 gigahertz to 1.88 gigahertz. Then these 4 peaks ensure they have a 4 LTE signal is coming for the nearby station. Okay, and this one is the power. This one is the power we obtained from the peak. First peak, the received power is negative 47.76 and the actual power is negative 53.56 dBm. And the second peak, the received power we get is negative 57.18 dBm and the actual power is negative 62.98 dBm. And for the third peak, the received power we get is negative 52.60 dBm, and for the actual power is negative 58.40 dBm. And for the fourth peak, the received power we get is negative 55.54 dBm, and the actual power we get is negative 61.34 dBm.
And then from here, actually based on the actual calculation, after reduces from gain and also the loss from the cables. As you can see, the average results were shown between close to negative 60 dBm. The reason why is because every operating tower actually operates at negative 60 dBm when you're in range. So if you have a stable power, so you'll probably get within 50, 60 to 70 dBm. We also probably exclude probably the obstacles and everything, but this is we will get close to the result obtained from the base tower transmit power.
Yeah, because the assumption is made that we neglect all the losses, because all the losses here between the received and the actual is between, I think, plus minus 5 or 6 dBm.
Yes.
So moving on to the next.
So for this one, we were able to identify there's actually 4 peaks like Sun had mentioned. The first peak actually we did measure was at 1.8 to 1.82, and then the actual bandwidth from it is 1.805 or 1.832. This is actually coming from Maxis, because Maxis actually operate at 1.8 to 1.82. The second peak will be U-Mobile. Although we see the power is a bit lower, but we actually can show that it already shows that there is actually a significant peak over here. So the obtained LTE band was 1.825 to 1.84, and the actual LTE band we got was 1.825 to 1.84. So it's more or less the same. And then the third one peak will be at Cellcom. Cellcom operates obtained bandwidth at 1.84 to 1.86. And the actual we got from it was 1.841 and 1.857. Lastly will be Digi. Digi have a slightly higher power peak, which we obtained the bandwidth actually, it should be operating at 1.86 to 1.88, and the results we got was 1.86 to 1.88 also. Okay, from here we do identify that these 4 signals actually are the LTE signals come from it. So all 4 of them, because it's not too clear, it's obtained from websites. So this is actually our experimental locations, the same place here, 4 places, and our antenna is actually pointing out to the streets, to the main highway. So the red lines here, as you can see, those are LTE signals. These are given by Cellcom, Digi, Maxis, and U-Mobile. So now I think we're going to play you a video on the demonstration we did on tower block level 4 to do the experimental work in order to obtain the results.
Enjoy!